The National Electrical Code does not explicitly detail how to restore power after a flood, but general guidelines and safety standards offer a framework. Firstly, prioritize safety. Always wear appropriate personal protective equipment and adhere to all safety protocols. Never enter standing water where electrical shock is possible. Secondly, thoroughly inspect all electrical equipment, including pad-mounted transformers and air conditioning disconnect switches. Look for water damage signs such as corrosion, rust, or insulation failure. Thirdly, employ a qualified electrician to test all electrical equipment, ensuring its safe operation. Testing should include insulation resistance, ground fault protection, and other relevant parameters. Fourthly, remove any debris and clean affected areas thoroughly. Allow equipment to dry completely before re-energizing. Fifthly, document all inspections, tests, and repairs performed on electrical equipment. NFPA 70E, the standard for electrical safety in the workplace, emphasizes de-energizing electrical equipment before working on it. NFPA 70B, recommended practice for electrical equipment maintenance, advises inspecting and testing electrical equipment before returning it to service after flood exposure. Focus on pad-mounted transformers. These high-voltage units should only be handled by qualified electrical personnel. Replace the transformer if there is any water damage or contamination. For disconnect switches, inspect for water damage and ensure proper operation. Verify that contacts are clean and dry before re-energizing. When inspecting, look for corrosion, which appears as a reddish or whitish deposit on metal surfaces, indicating electrochemical degradation due to water exposure. Rust, a specific type of corrosion affecting iron and steel, appears as a reddish-brown flaky layer. Insulation damage might manifest as cracking, swelling, or discoloration of insulating materials. Qualified electricians use specific tools for testing. Insulation resistance testers, also known as megameters or megars, measure the resistance of insulation to detect leakage currents. Ground fault circuit interrupter testers verify the proper functioning of ground fault protection devices. Multimeters measure voltage, amperage, and resistance to check circuit integrity. Thorough cleaning involves removing mud, silt, and other debris. Use appropriate cleaning agents that won't damage electrical components. Drying can be expedited with fans or dehumidifiers, but ensure components are not exposed to excessive heat. The documentation should include dates of inspection, names of inspectors, detailed descriptions of equipment conditions, test results, and repair actions taken. For pad-mounted transformers, check the oil level and condition if applicable. Look for signs of water ingress into the transformer tank. For disconnects, ensure the operating mechanism moves freely and that all connections are tight. Regarding personal protective equipment, or PPE, use rubber insulating gloves rated for the voltage involved. Wear safety glasses or a face shield to protect against splashes and debris. Wear appropriate work boots that provide electrical insulation. Use insulated tools designed for electrical work. Always maintain a safe distance from energized equipment when possible. In testing insulation resistance, a megameter applies a high direct current voltage to the insulation and measures the leakage current. A high resistance reading indicates good insulation, while a low reading suggests insulation breakdown. Ground fault protection testing verifies that the ground fault circuit interrupter trips quickly when a ground fault is detected, preventing electrical shock. Cleaning should be done with non-conductive brushes and cloths. Avoid using water or conductive liquids for cleaning energized equipment. Ensure the equipment is completely dry before re-energizing to prevent short circuits and equipment failure. The documentation should also include photographs of the equipment before and after cleaning and repair. It's crucial to consult with a qualified electrical engineer or electrician for guidance and to ensure equipment and personnel safety. Their expertise is essential for assessing the extent of the damage, conducting necessary tests, and implementing appropriate repairs. Further specific considerations might arise depending on the age and type of electrical equipment. Older equipment may have more vulnerable insulation and wiring. Consider replacing aging equipment rather than attempting to restore it. Also, check for any local regulations or codes that may apply to flood-damaged electrical equipment. Local authorities may have specific requirements for inspection and testing before re-energizing. Moreover, be aware of potential hazards associated with re-energizing electrical equipment after a flood. There is a risk of electric shock, fire, and equipment damage if the equipment is not properly inspected, tested, and repaired. Never attempt to re-energize electrical equipment unless you are qualified to do so. Consider the potential for hidden damage within walls and underground. Water can seep into walls and conduit, causing corrosion and insulation damage that may not be immediately apparent. Therefore, it may be necessary to inspect wiring and components within walls and underground before re-energizing. Also, pay attention to the grounding system. A properly functioning grounding system is crucial for electrical safety. Ensure that all grounding connections are intact and that the grounding electrode is properly installed. Check for corrosion on grounding conductors and connections. Replace any damaged or corroded grounding components. In addition, consider the impact of the flood on the electrical distribution system as a whole. The flood may have damaged the utility's electrical infrastructure, which could affect the quality and reliability of the power supply. Contact the utility company to ensure that the power supply is stable before re-energizing. Remember, safety is paramount when dealing with flood-damaged electrical equipment. Take the necessary precautions to protect yourself and others from electrical hazards. If you are unsure about anything, consult with a qualified electrical professional. Furthermore, after the initial restoration, implement a preventative maintenance program. This program should include regular inspections, testing, and cleaning of electrical equipment to prevent future problems. Also, consider installing flood protection measures to prevent future flooding of electrical equipment. This may include raising electrical equipment above flood level or installing flood barriers. When documenting, keep detailed records of all repairs and replacements. This information will be valuable for future maintenance and troubleshooting. Consider using a computerized maintenance management system to track electrical equipment and maintenance activities. Finally, ensure that all electrical work is performed by qualified and licensed electricians. This will help to ensure that the work is done safely and correctly. Electrical work performed by unqualified individuals can be dangerous and may violate local codes. By following these guidelines and seeking expert advice, you can safely and effectively restore power after a flood while minimizing the risk of electrical hazards. Remember, prevention and regular maintenance are key to ensuring the long-term reliability and safety of your electrical system. Consult with local building officials and inspectors regarding the specific codes and regulations applicable in your jurisdiction. They can provide guidance on the requirements for electrical installations in flood-prone areas. Consider installing arc fault circuit interrupters for added protection. Arc fault circuit interrupters detect dangerous electrical arcs that can cause fires. They are particularly useful in older buildings where wiring may be more susceptible to damage. Also, be aware of the potential for mold growth in flood-damaged areas. Mold can grow on electrical equipment and wiring, which can create a health hazard and damage the equipment. Clean and disinfect affected areas to prevent mold growth. For buried cables and conduits, consider using ground-penetrating radar to locate and assess damage. Ground-penetrating radar can detect underground objects and structures, which can help identify damaged cables and conduits. In addition, check for signs of animal infestation in electrical equipment. Animals can nest in electrical equipment and damage wiring and components. Remove any animals and repair any damage they have caused. Review the electrical load calculations to ensure the system is adequate. After a flood, there may be changes in the electrical load due to new equipment or appliances. Make sure the electrical system can handle the increased load. Consider using surge protection devices to protect sensitive electronic equipment from voltage surges. Surge protection devices can divert excess voltage away from equipment, preventing damage. After restoring power, monitor the electrical system closely for any signs of problems. This may include flickering lights, unusual noises, or hot spots. Investigate any problems immediately. For submerged motors, consult with a motor repair specialist. Submerged motors may require special cleaning and drying procedures to prevent damage. Finally, educate occupants about electrical safety after a flood. Make sure they know how to identify potential hazards and what to do in case of an electrical emergency. Regularly inspect and test backup generators to ensure they are working properly. Backup generators can provide power during outages, but they must be properly maintained. Consider using a thermal imaging camera to inspect electrical equipment for hotspots. Thermal imaging cameras can detect heat signatures that indicate potential problems. Implement a lockout-tagout procedure before working on electrical equipment. Lockout-tagout procedures ensure that equipment is de-energized and cannot be accidentally re-energized while work is being performed. Establish an emergency plan for electrical outages. The emergency plan should include procedures for shutting off power, evacuating the building, and contacting emergency services. Moreover, consider the long-term effects of flooding on the electrical system. Repeated flooding can cause cumulative damage that may not be immediately apparent. Implement a long-term maintenance plan to address these issues. When selecting replacement equipment, choose equipment that is designed for use in wet environments. This equipment is typically more resistant to corrosion and water damage. Also, consider the location of electrical equipment when planning new construction or renovations. Avoid locating electrical equipment in areas that are prone to flooding. For solar panel systems, inspect the panels, wiring, and inverters for water damage. Solar panel systems can be particularly vulnerable to flooding. Ensure that the battery backup systems are properly sealed and protected from water damage. Battery backup systems are essential for maintaining power during outages. Consider using uninterruptible power supplies for critical equipment. Uninterruptible power supplies provide backup power in the event of a power outage. Review the insurance coverage for electrical equipment. Make sure the insurance policy covers flood damage and that the coverage is adequate. Finally, document all communication with utility companies, building officials, and insurance providers. This documentation will be helpful in resolving any issues that may arise. Remember to always prioritize safety and consult with qualified professionals when dealing with flood-damaged electrical equipment. Regular maintenance, preventative measures, and proper planning can help to minimize the risk of electrical hazards and ensure the long-term reliability of the electrical system. By adhering to these comprehensive guidelines, you can ensure a safer and more efficient power restoration process following a flood event. This will protect both property and personnel from potential electrical hazards.